Up next, we'll hear from Sizwe Lamini with PowerHV. Sizwe was voted most likely to enjoy the majestic landscape of Manitoba, especially its yellow fields of canola flowers. Sizwe, I can see you, and I can see your slides.
Good afternoon, everybody. We at PowerHV help companies to improve the performance of their assets with smart real-time monitoring that helps them to increase revenue and reduce losses. The problem that we address is that the sensors which are out there, especially for monitoring of methane leaks, were developed before the regulations that are out there. And those regulations require monitoring per equipment, as well as the rate of leak of methane from those pieces of equipment. At PowerHV, our solution helps operators to comply with those regulations for methane monitoring. We detect the leak at the piece of equipment and not just at the perimeter as our competing products do. We also apply edge analytics in order to diagnose the actual condition of that piece of equipment and not just send data to the customer. And we go one step further. We allow the operator to predict when a failure is likely to happen by monitoring changes in the vibration signature of a piece of equipment. With all this, we help the operator to comply with regulations. There are many types of competing technology for methane detection, including satellite surveillance, as well as laser detection, which is normally placed at the perimeter of well sites, including infrared cameras, as well as drone systems, none of which comply with regulations for monitoring of methane leaks. With our types of sensors and software, for instance, at a site with 6 wells, we would put 10 sensors. The reduction in methane would be 19 tons per year at that site, with a payback of 2 years and an annual return of $20,000 per year at that site from the reduced methane leak, as well as from the reduced carbon taxes. An operator, for example, with 140 wells, that would be a saving of 1,400 tons per year of methane, a payback of 2 years, and an annual saving in methane and carbon tax of $1.5 million per year. Globally, in the methane leak problem, there are new laws that have been passed which require monitoring of methane and reporting of methane leaks. These are new laws, most of them developed before those sensors, after those sensors which are currently deployed. Going together with these laws is an increasingly activist, environmentally active public who have access to data, for instance, from the IEA satellite website, which can indicate any well site which may be in the vicinity of that activist public, who can then take that operator to court and litigate. Globally, the size of the problem is $117 billion per year. In Canada, it's worth $2 billion. In the United States, it's worth $12 billion. As a company, we started out servicing the electricity sector. In 2020, we sold $400,000 of sensors and bushings to the electricity sector. In 2021, this year, we are on track to sell to generate $2 million in revenue. Last year, we raised $350,000 in investment. And this year, we have recently been funded with $2 million to help us to scale our operations and grow the company. We aim to come back to investors in about 2 years' time, in 2023, to raise $10 million in order to keep growing our company. We have an experienced technical team, as well as finance and business development team. On our board of directors, we have investors. We also have advisors who have deep industry experience in procurement and sales, B2B, in the sectors where we operate, as well as technical experience in oil and gas and electricity sector. We are members of industry associations in the sectors where we operate, which is the electricity sector and oil and gas. We have sensors that we deployed in the electricity sectors that we have changed the enclosures to make them adaptable to the oil and gas sector. We have not changed the core platform and technology, and we have bushings which are deployed in the electricity sector. What we are asking for as we present today is introduction to medium-sized well operators who would like to do some demonstration pilots, and we would like to have some partnerships with some of the other sensor manufacturers who would want to use our type of technology in addition to what they have currently. Thank you very much. I'll be able to take questions.
Thank you, Sizwe. We have a couple questions already loaded up. First one is from Vincent. What is the size of leak detected at what distance and range of action?
We focus on what is classified as large leaks. So those large leaks have a flow rate which is specified in the regulations. I think if I remember correctly, it is, it's 135 feet per second or something like that. But we focus on detecting larger leaks, and we focus on the equipment that is emitting those leaks, such as compressors and the equipment that are specified in the regulations. Thank you.
Another follow-up question from Vincent. Where are your sensors built? Where is your IP? And what is the sensing technology?
We build our own sensors. We have our own proprietary sensor specifically developed for partial discharge with detection. We add methane detection sensors, vibration sensors, audio, and other sensors, so that when we detect a methane leak, we have multiple sources of inputs that allow us to know that this is definitely a leak and not a false alarm. And our intellectual property, we have one patent, which is for bushings, and we are filing some patents for sensors. So those are ongoing and in progress.
A question from Zenub. How do you differentiate between other methane sensors available in the industry and your technology?
There are many types of sensors. Our focus is monitoring per equipment. So many of the other sensors, they monitor at the perimeter of the site. So they don't give information about the specific piece of equipment and its leak. You need an additional resource, which is normally a person with another additional instrumentation that they walk around and look for the actual location of that leak.
Okay, we have a few additional questions in the chat. Just a reminder, please try to use the question and answer function if possible. First one is from Raj. He's looking for a couple more specifics on the sensor. Are your sensors at the ground level or elevated? Do they allow you to pinpoint the source of the leak and the leak rate, or just give you concentrations at the sensor? And does it detect only methane or other volatile compounds and pollutants?
Yes, at this stage, we are focusing on methane detection. We locate at the piece of equipment. So wherever the equipment is located, elevated or on ground, we locate wherever that equipment is located.
Okay, we got a couple others in the question and answer box. How do you keep wind from affecting your readings?
So wind is always there, but because you are close to the location of the leak, and because we are monitoring what is defined as large leaks, the rate of flow, as well as the audio from that leak allows you to detect without any doubt that this is a methane leak, and you calibrate it by calculation inside the software to say this is the rate of leak of this type of methane leak.
Thank you, Jerry, for the question. Next one from Elliot. Are your sensors a complete substitute for alternative sensing methods, or would they be combined with alternatives for an optimized site?
We would combine them with alternatives for a site so that you would have the perimeter detection and you would have a specific location, which is using our sensor. You can also use them as an alternative standalone at sites that don't have sensors. We are just optimizing and reducing the time that it takes to detect that leak and be able to address it.
A question from Andrew. What is your pricing model? Has this been field tested?
We have a pricing model that we based on competing types of sensors in the oil and gas, as well as electricity sector. And we would normally, we have an element, which is the hardware, the sensors themselves, and then a software license that would keep our engineers updating as, the operating systems change. But we can discuss in more detail with individuals, after this discussion.
Very good. We've run out of time. Sizwe, I'd ask you to look at the chat. There's a couple other questions that I might not have addressed in there. Thank you, Sizwe.
Thank you.